In note 6.5, day 2, examples 5 and 6, we're going to be graphing general secant and cosecant functions. So something of the form y equals a times the secant of the quantity bx minus c plus d, or the corresponding form for cosecant. When you're graphing secant and cosecant, it's easiest to first graph the reciprocal function. So for secant, we'll graph the corresponding cosine function, and for cosecant, we'll graph the corresponding sine function. So in example 5, we're asked to graph y equals negative 2 secant 4x. So the first thing we're going to do is think about the reciprocal function, which is y equals negative 2 cosine of 4x. So this will be a good review of how we graph cosine and sine functions. So the first thing we want to know when you graph a cosine function is where is the axis of oscillation. So for this function, there's no vertical shift, so it's at y equals 0, and I will put that on our graph. So I'm going to put y equals 0. This is the midline. The next thing we want to know is what's the amplitude. The amplitude comes from the absolute value of a, where a is this coefficient in front of cosine. So for this function, the amplitude is 2. And from the midline, we're going to move up 2 units and down 2 units. I'm going to put a scale on my y-axis of 1 unit is 1 square. So I'm going to draw in a dashed line for the maximum values on my cosine and the minimum values, using the amplitude to go up 2 and down 2. The next thing I want to know is the period, because that will help me set the scale for my x-axis. So the period for cosine is 2 pi, which is the period of the parent function, divided by b. So in this function, b is 4. So the period is going to be pi over 2. And key points are going to occur at intervals of every 1/4 period. So they're every 1/4 period. So that'll be 1/4 times pi over 2, which is pi over 8. So when we set the scale on the x-axis, pi over 8 is going to be a helpful unit to use. The next thing we want to know is the starting point. So the starting point we can find by transforming one point on cosine, since we know the pattern. So for a cosine of x, it starts at a maximum, so 0, 1, and then we'll go ahead and perform the transformations. So in this function, x values are being multiplied by 1/4. So we're going to do x values are times 1/4. So 0 times 1/4 is still 0. And y values are going to be multiplied by negative 2. So y values are going to be multiplied by negative 2. We have a reflection over the x-axis and a vertical stretch by a factor of 2, right? If I wanted to put the transformations, I could, right? So this is a vertical stretch by 2 and a reflection in the x-axis. If I wanted to list the transformations, I could do that. So the y value was 1. It will become negative 2. So that will be our starting point. And then the last thing we need to think about is it is reflected. So we already mentioned that. So let's go ahead and sketch in cosine. So I'm going to put in our starting point at 0, negative 2. And then the x-axis scale, we said a good unit to use would be pi over 8. So I'm going to count by pi over 8. So 2 lines are pi over 8. The next 2 lines are 2 pi over 8, which becomes pi over 4. 3 pi over 8. 2 lines over will be 4 pi over 8, which becomes pi over 2. 5 pi over 8. I can't simplify that. 6 pi over 8 becomes 3 pi over 4. And then I'll count in the negative direction. So negative pi over 8, negative pi over 4, negative 3 pi over 8, and negative pi over 2. And now with cosine, every quarter period, which on this graph is every pi over 8, we get a new key point. So we were at 0, negative 2. We'll be at pi over 8, 0, pi over 4, 2, 3 pi over 8, 0, pi over 2, negative 2, 5 pi over 8, 0, 3 pi over 4, 2, etc. So I'm going to copy this pattern. And notice this is reflected cosine function. So it does start at a minimum, and we have no choice except to move upward from the minimum. when we're graphing this. So I just sketched in the reciprocal function, and now I'm going to sketch in the real function that we want, which is secant. So when graphing secant, everywhere the graph of the reciprocal cosine function crosses through its midline, I'm going to draw in a vertical asymptote. So that's at x equals pi over 8, x equals 3 pi over 8, x equals 5 pi over 8, x equals negative pi over 8. Let me fix that one. That one didn't turn out so well. X equals negative pi over 8. And x equals negative 3 pi over 8. Those are our vertical asymptotes. Okay, I'll label a few of them. And now we can sketch in secant. And when graphing secant, if you just show the relative maxima and minima points, that's sufficient. So it will go through 0, -2, and then the branches will go downward towards the vertical asymptotes. Pi over 4, 2, and the branches will go up. Pi over 2, -2, branches going down. And we can fill in the pattern. And now we have graphed y equals -2 secant of 4x.